Hello and welcome to the Consulting Specifying Engineer webcast, Lighting and Lighting Control Design, sponsored by Lutron. I'm your host, Amara Razgis, with Consulting Specifying Engineer and CFE Media and Technology, and I'll be with you for this hour-long event. All right, let's learn about this webcast platform. If you are having trouble with your slides or with the audio, refresh your internet browser or click on the Refresh Media button directly under the presenter's photo. You can adjust the volume for this webcast on your own device. If you're having technical problems, click on the question mark at the top right corner of your screen to do some system checks before contacting an online technician. If you do need help, type a message in the Ask a Question box and we will respond in the Answered Questions box. To download the presentation slides, use the Event Resources tab on the left side of your screen. Type questions for the presenters in the Ask a Question box on the left side of your screen. And you can ask questions at any time during this presentation. The Q&A will start in about 45 minutes. If you're interested in receiving one AIA CES approved learning unit, you need to pass a 10-question exam. To take that exam, you can click on the Learning Unit Exam tab at the top of your screen. That quiz will pop up in a separate browser window, so I do recommend that you open it now because that link will break when the webcast signs off. In keeping with the American Institute of Architects Continuing Education System Policy, please take a few moments to read this quality assurance slide. Here are the learning objectives for today's session, and we'll talk about all of these in the presentation. Please note that any blue underlined text that you see is a hyperlink within the PDF where you can get more information. Let's now hear from this session's sponsor. At the conclusion of the commercial, you may experience a few seconds of silence to make up for different internet speeds. Please stay tuned with us for the next minute.
Every year, thousands of buildings are built or retrofitted. Every one of these spaces can benefit from smart lighting control that saves energy, improves comfort, and enhances productivity. Vive from Lutron is a simple, flexible, and scalable smart lighting control solution comprised of a full family of wireless devices that can be tied together to enable centralized control, monitoring, and system integration. Vive can help buildings meet stringent energy codes and improve building performance on budget and on schedule. And with a wide range of online supporting tools, meeting energy codes has never been simpler with Vive. Determine the energy codes in your project's location, design confidently with code-based application guides, and create your documentation quickly with room-based design files. Vive, the simple, flexible, scalable lighting control solution. The world leader in smart building lighting control solutions.
All right, very nice. That support is greatly appreciated. So now we've lined up two really fantastic presenters. Tony Staub is Lighting Design Lead and Electrical Project Engineer at Specialized Engineering Solutions, where he just started a few weeks ago. He earned a Master's of Architectural Engineering from the University of Nebraska and then focused on knowing everything possible about lighting and lighting controls, allowing him to help clients design comfortable, productive, and user-friendly environments. Michael Chow is principal, owner, and founder of Metro CD Engineering. He received an electrical engineering degree from Ohio Northern University, where he now serves on the ONU College of Engineering Advisory Board. He is a Consulting Specifying Engineer 40 Under 40 award winner and a member of the Editorial Advisory Board. Well, I'm eager for Michael to get started, but first we have to ask the audience for some input so we know which direction to take. So we're going to launch our first poll here. And if you would take this first poll and let us know, what is your role in lighting or lighting control systems? So we're looking for a little bit of background about you, to get a better understanding of how to direct this presentation and understand exactly who we're speaking to. I'll give you a couple of seconds here to respond to this poll, and it looks like the vast majority of our audience today is electrical engineers. Okay, so vast majority is electrical engineers, and then we do have some folks who are engineers, though not necessarily electrical. So thank you so much for taking that poll. We'll ask you a couple more questions as we move on. And now, Michael, it's time to get started.
Thanks, Samara. So when we're taking a look at lighting and lighting control systems, the first place to start is to take a look at the codes, guidelines, and standards for lighting. So as Amara mentioned earlier, the following items that are listed here, we're not going to go through every item. We'll hit just the key ones, but the slides will be available after the presentation, and you'll be able to click on the wording or that particular document, and it will direct you to the website. So we're going to be focused mostly on ASHRAE standard 90.1. That encompasses HVAC, mechanical, power. Lighting is also included in there, and we'll talk about that particular standard in a little bit more detail later. So here are some more code standards and guidelines. We'll be talking more about the International Energy Conservation Code, and we'll also be talking about the IES. Tony will be going into some more detail. The IES is Illuminating Engineering Society, and they have online documentation where they provide recommended foot candle levels for specific tasks and spaces, and also dependent upon the occupant age. The U.S. Department of Energy, we'll talk about that a little bit more as well too. They administer the ComCheck, which most of you should be familiar with that. That is a web-based or application-based system that allows you to show compliance with the energy codes. The U.S. Green Building Council, that's also LEED, and LEED has certain requirements related to lighting and commissioning. And the WELL building standard is also one that has a lot of lighting as far as the design is concerned, and goes into a lot of the quality of the lighting. And there's federal, state, and local requirements as well too. So ASHRAE 90.1 that was mentioned earlier, this is the one that I use most often. It's updated every 3 years, and the 2022 update is forthcoming. So again, it's updated every 3 years. It's similar to the IECC. It covers the most aspects of energy efficiency in buildings, as we talked about earlier. Lighting is part of that, one of those systems. So some jurisdictions adopt this code, and they also publish their supplements and amendments. For example, I'm in Ohio, and there is a supplement where certain requirement of the 90.1 is not necessary, and that's the 50% receptacle control. So in Ohio, that is exempt. Okay, next we'll talk about the International Energy Conservation Code, and this is published by the International Code Council. It's also updated every 3 years, and the most recent update is 2021. And just like the ASHRAE 90.1, it covers the building systems and lighting. Now, it's not a carbon copy of ASHRAE 90.1 when it comes to lighting. There are the lighting items are very similar as you go across the two documents, but they're not exactly the same. So there is a section in the IECC that notes that ASHRAE 90.1 is an acceptable alternate compliance path. So that allows you to use either one. And this this next item, basically, since they're 3 years, they're published every 3 years, typically the IECC allows you to adopt the 90.1 version issued 2 years before the IECC version. Now, keep in mind that there might be specific requirements. For example, in Ohio, the 2012 IECC is in effect, but the ASHRAE 90.1 2007 is also in effect. So that's slightly different than what's stated here. Next is Title 24 for California. This is one of the energy codes that is not directly based upon either the ASHRAE 90.1 or the IECC. It is also updated every 3 years. And Title 24 is something that some of the items that are in there actually get incorporated in ASHRAE 90.1 or the IECC. An example is vacancy centers. Those were first introduced in Title 24, and they eventually made their way into LEED and ASHRAE 90.1 as well. So next, Tony is going to continue the discussions on codes.
So these codes are something that I'm glad to see that we've got quite a few electrical engineers here, and these are codes that you should be familiar with regardless then. But I'm going to touch on a few of the lighting specific things that are held within these codes. So NFPA 101, the life safety code, this is where you find the requirements that lay out what is necessary, what is required for emergency operation especially, but for egress as well. There's a couple things in these codes that I see get sort of missed or misunderstood from a lot of people, just because the lighting pieces of these can be a little bit hidden in depth from all the other things. So NFPA 101, one of the biggest ones there is required illumination levels on stairs. Go take a look. 10-foot candles on every stair tread. That's one that in my experience has sort of commonly been misunderstood or missed. NFPA, or National Electric Code, again, super familiar with that code, right? We use it every day. Where we're really using that as it applies to lighting is in how we are setting up the electrical systems to serve specific lighting functions, right? So depending on what type of building you're in, I personally do a lot of healthcare engineering. And that healthcare, we are looking at 517 a lot, where there are very specific requirements about what lighting can and should be placed on the life safety branch, on the critical branch, on the equipment branch, and on the normal branch. So it's really telling you sort of how to organize the circuitry for your lighting. And then finally, IBC does have some of the, it's really a lot of the same sort of language that's used in NFPA 101. It's telling you a lot of the same things. This is where the 90 minutes for emergency egress lighting and things like that are showing up, are between NFPA 101 and IBC. They sort of double cover a little bit. Michael's going to help us determine which codes are applicable for your project.
So thanks, Tony. As we mentioned earlier, that the ComCheck is available for the Department of Energy. And if you go to energycodes.gov, that's a great resource. If you click on that link, it will take you to a website where you can enter the state that your project is in, and it will tell you the current year for ASHRAE 90.1 that applies, and as well as the IECC. Now, some cities and counties adopt their own energy codes that may be more stringent than the state level. And Tony has an example that he would like to share.
Yeah, so we have a very interesting, I'll take on just a little short story here with what we deal with, especially in Nebraska. So we had a situation where the state code was recently updated to a 2018 IECC, and we have this exemption in Nebraska where if a renovation project is under 50% of the insured cost of a building, you're actually not required to meet the state energy code. So we had situations where state energy code was a 2018 IECC, and many local jurisdictions had the 2009 IECC. And you really needed to understand both of those things at the same time, because you might have been in a position where I'm in Omaha, and a renovation project might not have needed to apply with the state code. In many cases, they didn't, but there was still a locally enforced code. So really, that's a cautionary tale to make sure that you are looking at both the state and local codes to see which ones are going to apply, because the state code might not matter at all, but you might still have a code requirement. So just make sure that you're checking all of those layers of different code requirements and make sure that you're meeting the most stringent code that you're required to meet. All right, Michael, you want to tell us about owner's project requirements?
Great, thanks, Tony. So the owner's project requirements, or OPR for short, it contains elements for design and should contain requirements for illumination and related items. So this document should be done at the beginning of a project. And this is, sometimes the owner will give you a list of items that they require. And sometimes there's some gaps. So it's important to have this dialogue with the owner to make sure that you don't end up all the way at the end of a project and find out that you didn't meet the owner's requirements. And sometimes the owner's requirements, they don't line up with the energy code. For example, we had a project where the owner wanted all halogen lighting, and that definitely did not meet the energy code. So we explained this to the owner at the beginning of the project, and we were able to work in energy efficient lighting while still meeting the owner's project requirements, OPR. So as far as these items that are listed here, Tony's going to get into some more of the details of the OPR, and I'll follow up with commissioning requirements, sustainability goals, and training requirements, as well as operations and maintenance requirements. So I'll turn it over to Tony to talk about the lighting construction budget first.
Perfect. Thank you, Michael. All right, so lighting construction budget, this is one of those things that can really be difficult to pin down, especially early on in the project. You're typically going to get a budget that is presented in a dollars per square foot number, right? And that can be really difficult to relate to what the actual project needs are. What does $5 per square foot for lighting versus $10 per square foot for lighting mean? And that's something that, in my opinion, starts to come as a factor of experience. I know if I'm seeing, and admittedly, I haven't run these numbers in the last couple of years to adjust for any cost increases that have happened, but typically you would see those costs maybe in the $5 to $10 range. And from experience, I would know if I see a $5 a square foot lighting budget, one, I know that's going to be pretty tight, hard to hit. But I know that my standard product is going to be more economical product. So I'm going to be looking for maybe more flat panels. Instead of high quality downlights, maybe I'm doing more of a surface mounted edgelit sort of situation with downlights, but always looking for ways, especially in those fixtures where you're using the hundreds of fixtures, your type A's, that you're conscious of the budget so that you're not specifying a high-end product when the budget is not there. It can be very beneficial to try to get the budget sort of broken out when you have higher finished spaces within a project, but maybe the lighting budget is $5 per square foot throughout the building, but then there's a few spaces where the owner wants sort of that higher finish level or a more interesting space, and they're willing to carry a separate decorative lighting budget, and that can pay for things like sconces and coves and feature pendants and any number of other things going on there. So it can be really difficult. You want to communicate early and often, and you also want to communicate the value of why you've selected the fixtures you are and why you've done the design that you're doing. And that's because, again, in my experience, lighting tends to be a very easy target once value engineering starts on a project. Sure, everyone's been in one of those meetings where the contractor will raise their hand and say, I can reduce the lighting budget by 25% if you let me select the fixtures, right? And maybe that's okay, but from a lighting engineering standpoint, there are a lot of key important things, and we're going to get into a couple more of those as we go through the next slides, that I really, really care about. And I want to make sure that my client is still getting a high quality solution that I can stand behind, regardless of where that budget sits. So be conscious of what you're specifying, because if you're specifying that Cadillac on a Ford budget, like, you could end up in a situation where you've spent too much money, and now you're going to have to value engineer to something that isn't meeting the design that you wanted. So that can also help if you get the contractor in a little bit early, right? So if your contractor understands what you're doing, and this is especially true on the control side, your budget might end up looking better as you move through the project. The reason I say that's especially true for lighting controls is we still have the networked lighting controls, the digital addressable lighting control systems are still new enough that contractors may struggle with the installation of those. And if they're not familiar with how the installation is going to work, then you typically see much higher installation costs than what's truly necessary. So educating both your client, your contractor, really the whole project team as to what you're doing and why can help you ensure that you keep the design that you want. And I throw an example up here. One thing that I do to try to lock that in early is as soon as I can get even a preliminary floor plan and a budget, I start to go through and just color code plans. Really high level, absolutely, you're not making final selections, locations, quantities, anything like that. But what you're doing is starting to relay that information of high level, what is my plan in each space type? And you can help yourself decide that by learning a little bit more about what the client's needs and wants are. So fixture selection is going to be a big one. There are thousands of different fixtures that you can put into your project. So there's going to be aesthetic choices. There's going to be budget choices. There's going to be functional choices, right? These fixtures are performing differently too. So all of those things start to add up and are part of your fixture selection process. Like I said in the last slide, I usually try to get this started at SD, and then ideally you can get that sort of locked in at the DD level with a fixture package that you can deliver to the team so that everyone's on the same page and understanding what the fixtures throughout the space are going to look like. A couple other things that I think that you should keep in mind that can really be critical. Color quality and color rendering index is the main way that we're measuring that still. I could talk for hours on TM30 as well, which is I kind of hope where the industry is going, but everybody should be familiar with color rendering index at this point. I would advise you to think about the spaces you're in. CRI 80 plus is very typical. That's what you're most often getting from lighting manufacturers. But CRI 90 plus tends to be a pretty minimal cost addition and is relatively easy to get, even when a cut sheet doesn't necessarily say that it is. And there are a lot of benefits that you can get by moving to a higher CRI. I mentioned earlier, I'm in healthcare, do a lot of healthcare engineering. I don't put any light in a healthcare space that is not 90 CRI. And just the benefits of being able to get the really true to life color rendering so that a physician can look at your skin tone or your eyes or whatever thing they're looking at, even discrimination between two different pill types. Maybe you have a pink pill and a maroon pill and they're kind of the same. You need to be able to tell the difference so that you don't misapply those things. So that high CRI, healthcare is one example. You have art in a space, that could be another example. Interior design studios love to have higher CRI so that they can really see what those materials look like in the true lighting that they should have, right? Another thing that your client might care a lot about, even if they don't understand that they care a lot about, would be the color temperature. So we see that color temperature tends to be preferred in regions in different ways. Here in the Midwest, 3,500 Kelvin's still by far the most common. I know there are places where even 5,000 Kelvin can start to be more interesting or is more preferred depending on the space, like I said. What I like to do, I have just a little box that has different colored LEDs ranging from 2,700 Kelvin to 5,000 Kelvin. And most of the time when you approach a client and you start to talk about color temperature, they understand different color temperatures. Everyone's seen warm and cool and understands what that means, but they don't know, what does that actually mean for my building? What am I going to get and what am I going to see? So they're relatively easy to get, and talk to a rep and see if one of them has a tool for you. But if you can just show them, here's 3,000, here's 3,500, here's 4,000, being some of the most common ones, that really helps them to understand what decision they're actually making. A lot of times the answer you're going to get is just match what we have, but this is a brand new building with a brand new client. You might have to go through that sort of educational process. So, all right, so what about the lighting control system? Now, I will say, in my experience, more often than not, the energy code mandates what you're going to get. You should definitely, absolutely be having these in-depth conversations with your owners or with your clients. And the reason for that is a lot of times, and especially as we've moved to this sort of new era where we're getting more of these digital interconnected controls, clients are starting to have more interest in how they interact with those controls. But at the end of the day, most of our projects, we're trying to meet those energy code minimums that we have to do. So I have a table here. This one's from the ASHRAE code, but you might be using any number of codes. As Michael mentioned earlier, 90.1 is very popular there. In Nebraska, we use mostly the IECC, and that's largely because of the receptacle requirement. We don't have that exception, and very, very few people want to turn off their receptacles. So IECC is pretty common here. But really, what we're looking at is, what is the code making us do? We can look at other layers to save more energy, be more user-friendly, whatever you want to do, whatever the client wants to do. But ultimately, we have to know what are the things that we must do. One of those that has really changed a lot as newer codes have been picked up, and I believe this started in IECC 2012, and I think just the previous ASHRAE for that. But one of the biggest changes that has happened over the last number of years was you can no longer, once you've met those energy, or once you're at that enforced energy code, you can no longer have an occupancy sensor turn your lights on to 100%. A lot of these new codes are no greater than 50%. And there are exceptions as well. But that was such a common design for so many years that now you start to have to think about how we're going to do that a little bit differently, right? So what about building on from that? In the previous slide, I talked about the code requirements and what really tells us what we have to do. If your owner gets a little bit deeper and wants to dive in, you can start to have really, really in-depth conversations about your controls. And part of this is driven from the fact that the industry hasn't really standardized on much once we've gotten to this new level of controls. Picture in the top right there, that is a traditional slide dimmer, right, with a switch. And then I put 3 different examples of devices that do the same thing that dimmer used to do. All 3 of them look totally different. You're going to interact with them in a totally different way. But at the end of the day, they do the exact same thing as that slide dimmer. Your owner might have a preference. I know I do. When I'm selecting switches and I'm selecting those types of things. And that's just at the most basic sort of manual control level, right? Our systems now are so complex where we can do things like load shedding, things like schedules, et cetera, like that there are the depth that the owner wants to get to, there's a lighting control system for that. If they want a floor plan view to be able to pick up anything and everything, and know exactly what the lighting status of a light in the storage room is while they're on vacation in Mexico, that's fine. We can do that. We can get that set up. So it's all about a conversation with your client about how deep do you want to go? Are we really only trying to meet code minimums? Or do we want to take advantage of some of these extra pieces that we can do? And then really focusing on what does the end user have to interact with? You know, are they familiar with the buttons? Do they know they can dim? I can't tell you how many times I've been at a post-occupancy walkthrough and people complain about a room being too bright, and I'll dim it. And they look at me like I'm some sort of magical wizard, right? Like, oh, you've just changed my life here. So a lot of conversation can help you with that lighting control system, assuming that you have a client that's sort of willing to engage with that conversation. Wanted to take a moment to talk directly about daylight harvesting, because it can be really tricky, and it's probably one of those fun code lighting control things that can be tough for you. So both ICC and ASHRAE have defined daylight zones now. There's actually 90.1 does have secondary daylight zones. I did just look into 2021. IECC does add secondary side lit zones as well. So daylight harvesting is only becoming more required as codes get newer and newer. There's only more and more spaces we're having to do daylight harvesting and really save all that extra energy, okay? So definitely something that if you're not familiar with, start studying now, because it's coming, and more of it is coming. So as to how we do that, really there's two common methods used in the industry today, and that is open loop and closed loop, which is essentially just saying, do the photosensors that we're using, are they looking at the space? Are they looking at the desk that I'm sitting at, judging the light there and adjusting accordingly? Or are they looking at outside? And whether that's looking at a window, or if the photocell's actually located outside of your building even, and picking up just a daylight. Both can be effective in different circumstances. Generally, we are doing the closed loop, or generally for me, we're doing the closed loop designs that are sort of within a space, but especially when you get higher ceiling heights is a big one, or if you have a lot of indirect light, and the picture on the bottom left there of the daylight, even that one would make me a little bit uncomfortable. There's a lot of uplight that's hitting that sensor, right? So depending on your site conditions or your room conditions, one may or may not, or one may be more appropriate than the other. So, okay, want to walk through the steps that are needed to sort of start, and every project can be a little bit different, but how do you start from step one and get to designing a lighting system that meets the OPR that we just talked about? So this is my really high level flow chart. And like I said, projects start anywhere. Sometimes you are thrown in at step 3 here, and you say, well, here's a project and it's due next week, and start laying out lights. That happens, right? Schedules happen. But if we have our way, you want to take that a little bit slower and a little bit more methodically. So ideally, you can start by identifying the needs of your space. That's at least how I like to look at this first. Go gather all your codes, gather your energy codes, gather your IES codes. This is an excerpt from RP29 here, one of the recommended practice documents from the IES, which I always recommend. If there is a recommended practice document for your building type, go find it. It's going to give you better direction than just looking at the IES handbook, sort of the overview there, right? So those RPs can be very valuable in that way. And then this is the one that can be really difficult for us as electrical engineers, and that's develop the lighting language. And this is where, this is working with your architects, your interior designers, the rest of the team. And this is where you have to think about using a different language than you might use as an electrical engineer typically. You want to be able to speak to the feeling of the space, the goal of how that space is supposed to be perceived. And at this time, you really shouldn't be talking about fixtures at all. I don't want to talk about a downlight or a cove or a linear or this or that. I want to talk about where light should be. And a lot of times this is where sketching can be incredibly valuable, because you're not trying to get fine details. You're trying to convey what spaces need to be painted with light, right? What parts of the canvas are most important to us from a lighting design standpoint. That also is going to help you, once you understand that, then you can start to select the pieces and the parts that you need to get there. But if you don't know what the feeling is supposed to look like, what the design's supposed to end up as, then how do you get to that design? You're really just guessing if you don't really have that feeling in your head ahead of time. And that's when you move on to the engineering of this. So you already know what foot candle requirements do I have in the space. I know how it's supposed to feel, which has helped me decide which fixtures I'm going to end up using. And now, how many of them do I need? Where should they go? And that's where you start to get really specific, perform your calculations, do your layouts, and work from there. And then finally, make the cleanest plans that you can for the contractor, right? We all don't want to have to answer RFIs. So if you can make a very clean, concise way of delivering that information, that's obviously going to be best. Detailed lighting control direction, that can get really difficult. I'm a big fan of using a published sequence of operations on your plans to really let everybody know, at least what the lighting control system's going to do or intended to do. But that's ultimately where you need to end up is somebody's got to build it, and this is where we tell them that. So, all right, I'm going to kick it back to Michael.
Okay, thanks, Tony. That was very informative. So to continue the discussions for the owner's project requirements, we're going to talk next about how to implement commissioning, training, and operation and maintenance manuals. So commissioning, so it's important to ensure that the systems are working as the lighting designer intended. So you could have this great lighting system, but if it's not working as intended, you're going to have occupant dissatisfaction and some of the other items we talk about here. But when you do the commissioning, you're reducing energy consumption. For example, this is a picture of an occupancy sensor we installed at one of our projects that will, as everyone knows, turn the lights off when the occupants are no longer present in the room. Reduce operating costs, client satisfaction. An example there would be occupancy sensors, again, making sure that they are used in the right applications. There's usually a major movement area and a minor movement area. In the major movement area, for example, you would capture somebody walking in the door, and then once they're seated at their workstation, then you would go with the minor movement. And sometimes a wall-mounted occupancy sensor isn't the best location for an occupancy sensor. So doing the commissioning and having a commissioning team, they would be able to catch those particular items during their design reviews. So the commissioning authority, which is abbreviated as CXA, reviews the OPR and design team's basis of design to ensure that the OPR are met. So ASHRAE 90.1 now requires functional testing of the lighting controls and systems. Here's an example when you're doing the functional commissioning, the commissioning out in the field. This is a project that we worked on where you had the HVAC ductwork just sitting on top of the ceiling grid and also would be sitting on top of the lighting fixtures. We were able to remedy this so that even though LED luminaires are great, at some point there could be a driver failure, et cetera. So you would need access in the space above, and doing some of this functional testing would help catch these type of items. And LEED, for example, requires fundamental commissioning, and there's an enhanced commissioning component as well too, where 10 months after the project is substantially complete, the commissioning team goes back out and verifies that things haven't changed, that the lighting systems are functioning as designed. Training, operations, and maintenance manuals, a lot of times this gets overlooked as we working on more and more complex lighting design and control strategies. The facilities personnel really need to be trained on how these things operate. For example, some occupancy sensors, they have adaptive technology. What that means is that it may take them a couple of days before they get the calibration tuned, and the facilities personnel may not, if they're not aware of that, they may be replacing those sensors thinking there's something wrong with them. So these are ideally videotaped and provided by a factory trained or authorized representative from the lighting controls company. And The specifications, this is usually covered in specifications to do this training. The O&M manuals, I think we're all familiar, the electrical engineers especially familiar with the review of the O&M manuals. This is just to make sure that the record drawings are as-built conditions and the specifications, any changes are documented. And the O&M manual should include the shop drawing submittals of the luminaires and the control devices that were installed.
All right, thank you, gentlemen. So before we move on, we're going to ask you our next poll questions. We have another survey for you. We want to get a little bit of feedback, a little bit of information. This next question is, what is your role in lighting or lighting control systems? And we're looking for details about, I'm on to the next poll question. Wow. So what lighting topics have you heard about and you want to know more about? So this is looking a little bit differently at what perhaps is new for you or perhaps is something that you work on right now, but you don't have a lot of information on. So we're looking to get details about what you want to know more about. All right, so far, interesting responses. So the number one response is advanced controls. And in second place, we have UV lighting and disinfection. Just moved ahead of that, daylighting. So number one is advanced controls. Number two is daylighting. Thank you so much for participating in that poll. And Michael, we're going to kick it back to you for some information about a recent project.
Okay, thanks, Tamara. So there's a case study that I'd like to share with you on a project I recently worked on. And this is the new engineering building at Ohio Northern University. This is where I went to college, and I'm also on the engineering advisory board. So this particular project had meant a lot to me, and it was the first LEED certified building on campus. So we start again with the energy codes. We went with ASHRAE 90.1 with the Ohio amendments, National Electrical Code that was adopted by the state of Ohio. And then this project actually was able to get not just LEED certified, but gold certified. So how did we accomplish this? We worked with the architect, and we also worked very closely with the owner of the university, and he wanted this building to make a statement about engineering. So all LED lighting fixtures were specified and installed. And at the time of this project, the watts per square foot that was allowed was 1.2 watts per square foot. The fact that we were able to use the LED fixtures, we were able to get that to 0.45 watts per square foot, which is a pretty significant reduction to the energy code. In fact, the plans examiner didn't believe us and required us to submit cut sheets of all of the lighting fixtures that were installed. And once the plans examiner had that, then we were able to receive plan approval. It also includes daylight harvesting.
All right, gentlemen, thank you so very much. All right, now that we've wrapped up this portion of the presentation, we know that that was a lot of information to take in. We do want to remind you that you can earn one AIA CES approved learning unit for this event. You do have to pass an exam. So to take the learning unit exam and to download your AIA CES certificate, use the Learning Unit Exam tab on the top of your screen. And the exam will open in a new browser window, so I suggest you open that window right now. And if you like this education and you want more, please visit CFE.edu. Right now we have several courses on electrical and power systems, and one focusing on motors. We will have virtual training week coming up pretty soon, so that's just a couple months away. We encourage you to register. All right, so let's take some questions. Please type your question into the Ask a Question box on the screen. And if you would please type the presenter's name before your question, you can direct it to either Tony or Michael. We'll get to as many questions as time allows today. And questions that we don't get to, they will be posted at www.cscmag.com and with the archive of this webcast. And as a final reminder to download the slides, please use the Event Resources tab on the left side of your screen. All right, Tony, I'm going to send this first question to you. And this is kind of going back to definitions and information. Please tell me, what are side-lit and top-lit zones?
Yeah, absolutely. So side-lit, I would say, are probably the most common. And that what's happening in a side-lit zone is when you have a window in a wall that is going to be serving your space. So the most common application, think about your 10 by 12, your 120 square foot offices on the edge of a building that have a window in them. That is going to be a side-lit space because the space itself has the window on the side of the room. And so deep into that space, you're going to have a defined side-lit daylighting zone. The light from that window penetrates so far into the space. A top-lit zone, there's really two great examples for it, and that would be clerestories or skylights. So there are different rules for how you are designing your daylight zones under a clerestory or a skylight. That's a top-lit zone. Those are typically going to be in all directions from that top-lit, or from your, if you have a skylight, it's going to push light sort of in all directions below it. If you have a window, it's really pushing from the exterior into the space. So yeah, that's the difference. Side-lit is typically going to be a window. Top-lit's typically a skylight or a clerestory.
Got it. Thank you. Michael, this next question is for you. So as an electrical engineer, do you look to the architect or the lighting designer to lay out the ceiling and the lights to determine the correct lighting levels and exit and emergency lights?
Thanks, Samara. That's a great question. I think there's a lot of electrical engineers present, and I'm an electrical engineer myself. So for certain type of projects, the architecture firm, sometimes they may have their own lighting designer. And from my experience, the architect and or their lighting designer, they lay out the ceiling, they pick out the lighting fixtures that they want. If there's any specialty lighting fixtures that they want, a lot of times they'll show me a website or a page out of a magazine, and they'll say, hey, I want this particular the fixture. And one of the things that they usually don't take into account is the illumination and also the energy used by those lighting fixtures. So one of the challenges is to be able to still meet the energy code, the construction budget, and still be able to achieve the recommended foot candle levels. So with the first step I usually take is go to energycodes.gov and start the comm check. What you don't want to do is wait till the end of the project to do your comm check, and then you find out, oh, architect and our lighting designer, these special lighting fixtures, we can't use those because we're way over our watts per square foot allowance. And those are items that should be part of ownership project requirements. And so by doing the comm check early and working with the architect and lighting designer, you can potentially accept or tell the architect or lighting designer that doesn't necessarily work because of either the cost or because of the watts per square foot. So it's a great question.
All right, very good, thank you. Tony, this next question is actually kind of a follow-up. Who, Tony, is responsible for the lighting control system sequences of operation?
So that is a great question. It's a fantastic question. And I would say that ultimately the engineer is responsible for that. The person that's specifying the lighting control system is responsible for creating the sequence of operations. But I'd like to put a little asterisk on that answer though. So we should be the ones that are understanding all of the code requirements, and that is going to drive a lot of the sequence of operations. And I sort of touched on that a little bit earlier, that a lot of times your clients are really just wanting you to do sort of code minimum. And if you do have a client that isn't interested in going past code minimum, isn't interested in the additional benefits you can get from a more advanced lighting control system, then it might be possible for you as an engineer to sort of completely own that, given you have a building schedule, because that is usually an important piece of the sequence. The best way for that to be put together is a collaboration between, at least between the client, facility director, whoever that is, and the engineer, so that you can start to talk about those desirable things that you can do, sort of in addition to the code. So what are your schedules? And do we need to have multiple layers of schedules? Does your building want to have a morning, day, night, late night sort of thing? If I don't have that information from an owner, I'm going to make my best guess, and you're going to get a day and a night, and that's what you're going to get. But maybe your building really operates in more levels than that, right? So it is the engineer's responsibility. However, you get a lot better product if it's a design team responsibility that everyone's involved in.
Sure, got it. All right, gentlemen, this next question, I'm going to ask you first, Michael. Tony, if you want to chime in, you might have some input. Michael, what was the most complex lighting design project you've worked on? So if you could tell us a little bit about the challenges and then the solutions.
Sure, that's a great question. So one of the most complex lighting projects that we worked on was for a library, and they wanted to, they actually wanted to see the emergency lighting, not just the fixtures, but they also wanted to see, there's what's called a point-by-point, which I think most electrical engineers are familiar with. It basically shows you the lighting levels, and there's a way with the software, you can tell it to provide the levels at a particular height, whether it's the workstation height or at the floor with emergency lighting. So what made that project challenging was the plans examiner required that, but then the owner required multiple renderings using different types of lighting fixtures. And one of them was for a particular university here in Ohio. I'm not sure, maybe those of you in this presentation can guess the university, but they required a specialty fixture made up of specialty LEDs. So we had to model this, and we also had to design it. And once we did all that, and we thought this was going to be manufactured and put in, it got value engineered out of the project. So I think we heard that term value engineering quite a bit. And after spending all that time on it, it would have been nice to see the finished product. But yeah, there's some basic software that you can use to provide those illumination levels. But when it comes to modeling, sometimes you have to use a more robust, and usually that means more expensive lighting software.
Excellent. And Tony, do you have a complex project that you want to tell us a little bit about?
Yeah, I think, there's a huge list of different complexities I run into, but I think the one that comes to mind just right off the cuff would be if you've ever done lighting in a mass timber building, they can be very difficult to coordinate. So I was working on a university building that was going to be built mass timber with a lot of that exposed. The problem is we don't want to have surface mounted conduit all over the place, and there's this beautiful mass timber that we want to keep. But what that does is makes it a lot harder to do things like coves. Even to do suspended fixtures, you might be drilling through the floor slab of the floor above and using essentially a floor box or poke through to feed that device, right? Because you can't just core through the mass timber. So if you don't want to have exposed conduit everywhere, you have to really think carefully about what lighting tools you're using and how you get power to your lights in a situation like that. So I thought that was a really fascinating challenge.
Very cool. Thank you. Tony, I'm going to send this next question to you. This is directly related to the poll we just did. What are some UV lighting applications?
Yeah, absolutely. So near UV lighting has been around for a while. That was starting to sort of make a make some waves in the few years before COVID happened. What you really saw as soon as COVID hit was this industry shift to what can we do to help the world deal with this sort of pandemic. And that's where you saw sort of I'm going to call it a revival of UV. So we've known as a society, as a scientific community, that UV has helped for 100 years, more than 100 years. But it's being more well understood. And the problem with us not putting it inside of buildings is that UV, true UV light, can still be dangerous, right? We don't want to sunburns and things. But modern applications, to get back to the question, modern applications, you can look at, there's a lot of products now that are built with a lot of fail-safes to ensure people don't get the dangerous UV rays. There's also filtered UV products now that is out that it is safe for people to be under during certain times. But really what you're going to be looking at is any space where that an extra level of cleaning or cleanliness or sterilization is going to be beneficial. Now, where that's helpful could be any type of project. Do a lot of healthcare, an infectious control patient room, great spot for it, right? So the way that's typically done is going to be that a UV light will be at some height within the space, and warm air will kind of rise with all the viral load and everything in that space. The UV light purifies or sterilizes that, and then mechanical ventilation goes throughout the space to do the clean air. But even things such as schools, where you might have a bunch of I'm a childless person currently. You might have a bunch of sticky children kind of like around with a lot of dirt, and after recess they come back, and having that extra level of cleanliness in there just is going to help control the viral load in those spaces. So where should it be used? There's a vast amount of spaces where you might have benefit from that. And then it's how are you going to use it? Is it a space that is occupied most of the time throughout a day? Is it absolutely going to be empty for a couple hours a day? Your design is going to be different depending on how that space is used and what you're trying to accomplish.
Got it. I don't think we've covered sticky children before, so thanks, Tony. Michael, this next one's for you. How do you show cost of energy savings to a customer?
That's a great question. So in Ohio, with state projects, we have to be able to show a payback analysis that whatever lighting fixtures you're putting in, there will be a 5-year payback analysis. So what is included in that calculation? You'll have to find out the cost of energy you find out who the power company is, and typically find out from the owner what rate they're paying. And if it's more than just 5 years, with a cost analysis, we want to include maintenance costs in there. So one of the things about LEDs is that people think they'll last 20,000, 30,000, 50,000 hours. But it's been my experience that usually the ballast doesn't last that long. I'm sorry, not the ballast, the driver. Driver doesn't last that long. So we factor in the cost of replacing a ballast, and we can get the cost of the facilities person that's working for the owner. So we factor all these items into our payback analysis and our energy analysis. And that gives the owner or client a bigger picture of the energy savings and operational savings.
Sure. Okay. So we are running short on time, so we have time for only one more question. And Tony, this last one goes to you. What CCT do you recommend for healthcare specifically?
That is a very good question. So it's up to me to decide when I'm designing, I will typically go with 4,000 Kelvin. And here is my reasoning for that. So the way that our eyes perceive light, the way that the human eye is perceived, is that a higher color temperature, that more blue, is perceived as a brighter space. Okay. So there is then a theoretical benefit to having higher color temperatures because you can perceive that as a higher brightness. But then there's also that humankind tends to feel a little bit less comfortable once you start to get to a really high color temperature, 5,000, 6,000, 6,500 Kelvin. So I see 4,000 Kelvin as a really great compromise between good perception of brightness and comfort. And that's where I'm shooting for.
All right, excellent. Well, I'd like to wrap up by thanking our extraordinary subject matter experts, Michael Chow and Tony Staub, for surrendering so much information. Their extensive knowledge of lighting design has been greatly appreciated. Also, I would like to thank Lutron for supporting this education session. And before you go, we have one more poll. So a couple of quick questions will pop up for you on your screen as soon as this webcast ends. Please do answer those questions. We'd like to do better on the next one. And finally, on behalf of Consulting Specifying Engineer and CFE Media and Technology, thank you so much for joining us, and we'll see you at the next education session. Goodbye.